Hi, in this video we're going to look at using Pascal's triangle to find binomial coefficients. So the first example we're going to look at is use Pascal's triangle to expand to minus x to the power of 4. And I'll just write the problem. 2 minus x raised to the power of 4. So we need to use Pascal's triangle, the fourth row. So let's take a quick look at Pascal's triangle. The 0 row is 1. The first row 1, 1, 1, 2, 1, 1, 3, 3, 1. And finally the fourth row is 1, 4, 6, 4, 1. So we're going to expand 2 minus x raised to the power of 4. So the first coefficient we'll use is 1, so we're going to have 2 to the power of 4 plus 4 times 2 to the power of 3 minus x to the power of 1 plus 6 times 2 squared minus x squared plus 4 times 2 to the power of 1 times minus x to the power of 3, and the final term is plus minus x to the power of 4. So we'll simplify that. 2 to the power of 4 is 16. And be careful here, we have a minus x to the power of 1, so the next term is going to be negative. 2 cubed is 8. 8 fours are 32. 32x to the power of 1. And we've taken the negative into account. So the next term will be a positive because it's negative x will be squared. 4 sixes. We have 2 squared is 4. 4 sixes, 24 x squared. And the next term we're going to have a negative because it's a negative x cubed, and that's negative 8x cubed, and the final term is positive 4x to the power of 4. And that's the simple expansion using binomial Pascal's triangle. Okay, let's take a look at the next example. So the next example, we have to use Pascal's triangle to expand 3a plus 2b all raised to the power of 5. So we'll just move over to the maths pad and take a look at that example. The example was 2a. No, I'm wrong. The example was 3a. 3a plus 2b all raised to the power of 5. And we need the fifth row of Pascal's triangle. Now, if we remember from the last example, the fourth row was 1, 4, 6, 4, 1. So the fifth row will be 1, 5, 10, 10, 6, 5. Do that again. 1, 4, 6, 4, 1. And we have 1, 5, 10, 10, 5, and 1. Okay, so we're going to apply this to 2a. So we're going to have 1 times 3a raised to the power of 5 plus 5 times 3a raised to the power of 4, and 2b raised to the power of 1 plus 10 times 3a raised to the power of 3, 2b raised to the power of 2, plus 10 times 3a raised to the power of 2, 2b raised to the power of 3, plus 5 times 3a, that's raised to the power of 1, and 2b raised to the power of 4, and finally plus 2b raised to the power of 5. Okay, so we'll need to simplify each of those terms, and will we use the calculator to help us? I think maybe just keep the calculator to hand. So if I look at the first term was 3a raised to the power of 5. So let's just quickly check. 3 to the power of 5 is 200, and I'll bring it down here. 2, 4, 3, 243 a to the power of 5 plus. So we've 3 to the power of 4 times 5 times 2. Let's just have a quick look at that. So we'll take the calculator again, and maybe we can edit that back. 3 to the power of 4 times 5 times 2. That'll give us the coefficient we need here, and it's 810. So 810, and it will be a to the power of 4 and b to the power of 1. The next term, we have 3 cubed, 2 squared times 10. So let's have a quick look at that. So we can maybe clear this and do 3 cubed times 2 squared times 4 times 10, and the coefficient of the next term is 1080. So I'll just pop that down there, 1080, and that is a cubed b squared. The next term is 2 cubed times 3 squared times 10. That's the coefficient. We'll have a look at that. So we have 2 cubed times 3 squared, just call it 9, times 10 is 720. So we 720 a squared b cubed. The next term we have 5 times 3 times 2 to the power of 4. So we have 5 times 3 times 2 raised to the power of 4 is going to give us 240. And that is a to the power of 1 times b to the power of 4. And the last term is 2 to the power of 5, which I know is 32 b to the power of 5. And that's our last term, fully expanded, 3a plus 2b to the power of 5. Okay, well, one more example. And this example, we have to find the coefficient of x cubed in the expansion 3x plus 4 raised to the power of 5. So let's take a quick look at that one. So the problem we have, the expansion is 3x plus 4 raised to the power of 5, and we're interested in the coefficient of the x cubed term. Now we could simply go directly to that term. It is the fifth row of Pascal, which we know is 1, 5, 10, 10, 5, 1. And if I just start by saying 3x to the power of 5 plus 3x, 5 times 3x to the power of 4 times 4 plus 10 times 3x cubed plus times 4 squared. Well, I can stop here because this third term is the term that will give me the coefficient, and I'll just look at the coefficient. Now that's the number in front of x cubed. We don't need to include x cubed, so the coefficient of x cubed will be 10 times 3 cubed times 4 squared. So just bringing the calculator up, we have 10 times 3 cubed times 4 squared, giving us a coefficient of 4,320. So that's the coefficient of x cubed in the expansion given. So that's it for this video. Thanks for watching.